full width of a page. Some examples of block elements that we've seen so far are headings, paragraphs, unordered list, and list tags. Now let's look at inline elements. Inline elements do not start on a new line. This is the case unless they appear after a block element. It's because the block element takes up the full width, so it pushes the inline element onto a new line. I'm going to represent them like this. Inline elements only occupy the width of their content. Some examples of inline elements we've seen so far include anchor tags, images, line breaks, and inputs. Now, this distinction between block and inline elements may not seem that important at this point. It may just seem like good to know for now, but understanding the concept of block and inline elements is absolutely critical when it comes to CSS, because styling rules are heavily influenced whether an HTML element is block or inline. Let's take a look at block and inline elements on our Quill homepage. I'm going to right-click to go into DevTools. I'm then going to click on the inspector, and I'm going to click on this heading first. You'll notice that this blue box is extending the full width of the page. We know that this is a heading, it's an H2, and headings are block elements, so you can see it's behaving as you'd expect, starting on a new line and extending the full width of the page. We can see that this is the same for a paragraph element over here. Now, if I hover over this image, you'll notice the blue box does not extend the full width of the page. The blue box only takes up the width of the content, i.e. the image. And this is the behavior of an inline element. An inline element does not extend the full width of the page. It only occupies its content. If I scroll down, I flagged this funny behavior in a previous chapter, where we had our Quill logo appearing next to the Get Started anchor text. It was funny behavior because we're used to seeing elements start on a new line, but now we can understand why this is happening because of our knowledge of block and inline elements. We have a Get Started hyperlink, which is an anchor tag, which is an inline element, so will only occupy its width. And the image is also an inline element. It only occupies its width and doesn't start on a new line. So that's why our image appears next to the Get Started, as opposed to on a new line, because it's an inline element next to an inline element. And the reason the Get Started anchor tag starts on a new line is because it's being pushed down by the previous block element, this heading. Now what you'll notice is we actually have these images that aren't appearing next to each other, like you would expect inline elements to do. We can see that behavior over here, and at the top. These anchor tags would ordinarily appear next to each other. So why is that happening? To understand it, we need to look at nesting inline and block elements. An inline element can be nested inside a block element. Taking a look at the navigation bar on the Quill homepage, we have list tags, which are block elements. And inside our list tags, we have anchor tags, the login and register links. Anchor tags are inline elements. So we can see here, we have a block element, which is wrapping an inline element. So that is why the anchor tags and images we saw are not appearing next to each other. It's because they're being wrapped by a block element, which always starts on a new line and occupies its full width. Now, an important rule to remember is that placing a block element inside an inline element is invalid. Let's compare what is invalid and valid. First, looking at invalid. If I have an anchor tag, which is linking to a login page, and put inside the anchor tag a heading, we would then have an inline element, the anchor tag, wrapping a block element, the heading. And this is invalid. You can't do this. What is valid is to start with the heading, and inside the heading, place the login anchor tag. We would then have a block element, the heading, wrapping an inline element, the anchor tag. This is valid. And in fact, this kind of markup is fairly common. Looking at the AliG Wikipedia page, I'm going to right-click, inspect, and check out this hyperlink which says satirical. You can see in DevTools we have a paragraph, which is a block element, and the anchor tag is inside this paragraph element. We have an inline element inside a block element. And this is the case for all the hyperlinks inside this paragraph. They're all anchor tags wrapped inside the main paragraph tag. To help clarify this concept, I've created this table, which summarizes which elements you can nest inside another element. The rows of this table are the parent, and the columns are the child. Starting off with a block parent and block child. An example of this would be an unordered list with the list tags inside of it. This is valid, we can do this. Next up, we'll look at a block parent and an inline child. An example of this would be anchor tags inside a heading, and this is valid, we can do this. Moving on to an inline parent and a block child. An example of this would be heading tags inside anchor tags. This is not valid, we can't do this. And the final example is inline parent and inline child. An example of this would be an image inside anchor tags. This we can do, it is valid. Before we finish up, I want to show you an example where we have 3 layers on our Quill homepage. In our footer, we have our social media icons. They're images inside an unordered list. In our markup, we can see we have the image tag over here. This is an inline element. This is then wrapped by anchor tags, which is another inline element, and we know wrapping inline inside inline is valid. The anchor tag inline elements is then wrapped by our list elements. So our list element is a block wrapping an inline element, the anchor tag, which is valid. And then the list tags are wrapped by the unordered list tags. We have a block inside a block. So this is also valid. I'm going to go back now and select each element working up from the image to the unordered list. If I click on the image, you'll see that it's only occupying the width it needs to. If I then go a level above and click on the anchor tag, you'll see that it's also only occupying the width it needs to. Going a level up, I'm going to click on the list. And at this point, you'll see the blue box is extending the full width of the page. And that's because this is a block element. And finally, going a level up to the unordered list tag, you can see the blue box extends the full width of the page. Again, because this is a block element. So let's summarize this chapter and start to build out the summary card for this topic, called Containers and Semantic HTML. We covered block and inline elements. We started with block elements, which always start on a new line, and they take up the full width of the page. We saw examples of block elements like headings, paragraphs, unordered lists, and list tags. We then looked at inline elements. Inline elements do not start on a new line, unless of course they're directly following a block element. Block element pushes the inline element onto a new line. Inline elements only occupy the width of their content. And examples of inline elements are anchor tags, images, line breaks, and inputs. Next, we'll dive into 2 versatile elements used for structuring and styling web pages, div and span. We'll be discussing containers, the div element, the span element, and the differences between divs and spans. I'm going to start off by talking about storage containers in the real world. I live in a fairly small apartment in London with my wife, 4-year-old son, and 2-year-old son. So space is always an issue for us. So to help, I've got this shed in my patio area that at least once a month I'm in there sorting it out before it goes back to complete chaos. You can see it is currently in a state of chaos. So it is only a matter of time before my wife will be shouting at me to go and clean it up. Now, to help manage storage, not that it seems to be helping that much, you can see we have these large plastic storage containers. In my shed, I have 6 of these. A container for baby clothing for the ages 6 to 12 months, a container for clothing for 12 to 24 months, books, 0 to 6 months clothing, toys, and my work stuff. These containers help keep things organized and store related items together. So, what is a container when it comes to HTML? A container groups content and is used in conjunction with CSS to control the positioning and styling of content blocks. Here is the Notion homepage. You can see here in red, there are 2 section containers that contain 2 different kinds of content, and the content in the container is all related to each other. For example, the top container contains information about the companies that use Notion, whereas the bottom container is about a specific feature that Notion provides. You can also have containers within containers. you can see a smaller content container here in green, which contains all the logos of the companies using Notion. So how do we create these containers in HTML? To do this, we use the div element. The div element is a block-level container element used to group content for styling and positioning. The div element has an opening tag, a closing tag, and then you would put all the content you want inside these div tags, which for now I am representing by a comment, which says code block. Let's go check this out in action on the Notion homepage. I'm going to right-click and click Inspect to open up DevTools. You can see over here is a div, which is grouping all the content together related to companies using Notion. I can also go inspect the logos, and you can see here another div, which is used to group together all the logos. This div is nested inside the other div. So you can see we have containers within containers. I'm going to zoom out a lot on the Notion page, and I'm going to grab the Inspector tool and click on those main containers. You can see a container for this section, another container for this section, and another container for this section. So divs are being used to contain related content. Now I want to show you what I mean by the div being a block element. I've created this very simple HTML file. We have a heading, a paragraph, and 4 hyperlinks. Link 1, link 2, link 3, and link 4. Let's see what this looks like in the browser. So we know from the previous chapter, headings and paragraphs are block elements. They take up the full width of the page, like we can see here. Anchor tags are inline elements. They only occupy the width they need and don't start on a new line. And if you remember, the only reason link 1 is starting on a new line is because it's pushed down by the paragraph tag. What I'm going to do is now group link 1 and 2 together and link 3 and 4 together by adding in a div. I'm going to type div and hit enter. I'm then going to cut these 2 hyperlinks and put them inside the div. I'm going to do this again for the second set. Cut the anchor tags and put them inside the div. Let's refresh the browser to see what happens. You can see that link 3 and 4 now appear on a second line, and that's because the anchor tags are wrapped in a div, which is a block element. Let's inspect this on DevTools. You can still see the anchor tags themselves are only occupying the width they need to. However, because they're wrapped inside a div, and div is a block, the div element takes up the full width of the page, which forces link 3 and 4, which are also inside a div, onto the next line. So just remember, the div element is a block level element. It will take up the full width of the page and force any content below it in our HTML document to start on a new line. Now that we've looked at the div element, which is a block level container, we also have inline containers. An inline level container element is most commonly used to style a portion of text. This is the homepage of Canva, which helps you easily create designs for presentations, social media, and more. In the heading, the word design has been styled differently compared to the rest of the words. The styling has been applied in CSS, but to achieve this, the word design has to be inside a container, and it has to be an inline container. I want to show you why using a div element here simply wouldn't work. I've made a new HTML document called inline-container.html. All I have is a simple heading, where the text is the same from the Canva homepage. What will you design today? As I mentioned, the word design is styled differently, which is handled in CSS. But in order to achieve that, we have to wrap it inside a container. Let's try using the div container. I'll grab our div tags, cut the word design, and put it inside the div tags. Let's check this out in the browser. You'll notice a problem. The heading is no longer on one line. That's because the text design is inside a div, which is a block element. And we know that block elements take up the full width of the page and always start on a new line. So using a div container, which is a block element, for text doesn't work. We need an inline container element. So what is this inline element? It's called the span element. Let's say I have the heading Create Amazing Journals. If we later want to style the word amazing, we would need to wrap it in span tags. There's an opening tag and a closing tag. By doing this, custom styling can be applied without impacting the rest of the heading. In CSS, we would target this span and apply the styling, something we'll be doing soon in the CSS section. Let's check out the span in action on the Canva homepage. I'm going to right-click and open up the DevTools. I'm going to click the inspector icon and click on the word design. And you can see that the word design is inside this span, which is nested inside the heading, surrounded by the rest of the text. Now in the HTML, the text and span are appearing on separate lines. It's the exact same thing if it were to all appear on one line in the HTML. And just to give you a bit of a teaser for CSS, inside the Styles tab here, we can see this background image and this color property. If I turn them both off, you'll see it goes back to black. So with CSS, we're targeting this span and applying these two properties, which give the text this gradient look. Now, when I started learning about divs and spans, I found it a bit confusing to understand the difference between them and their exact purpose. To help with this, I want to compare divs and spans inside this table. First off, we'll look at divs. The tag for a div is div. They are used to group larger blocks of HTML content for styling and positioning in CSS. The div is a block-level element. Let's now look at the span element. Its tag is span. Span is primarily used to wrap text for custom styling. Span is an inline level element. As a general rule of thumb, you'll be using divs a lot more than spans, because every HTML document will need overarching structure, whereas not every page requires text to be styled in a certain way. And just remember, both the div and span may seem to have very little functionality right now, but they do become very, very important in CSS. Let's now finish off by adding to our summary card containers and semantic HTML. We looked at the div and span element. The div is a block-level element. In this snippet of code, there is an h1 and paragraph tag inside a div. Divs are used to group content. On the other hand, span is an inline-level element. In this snippet of code, we have an h1, and the span tags are being used to wrap the word full. Spans wrap text, which are later styled in CSS. Let's now go and see how we can add the div element on our Quill homepage. I've divided our page into different sections. The first is the navbar container. We then have the hero section, which is also a container. Next up, we have the features section. Then towards the bottom of the page, we have our call to action. And finally, the footer. So let's go and add div elements for all these sections. I'm inside our index.html file. You can see I've actually already flagged these sections with comments. So I'm just going to go add divs for each of these sections. I type div to get the div tags, and just cut the content and place it inside. And make sure it's correctly indented. Next for the hero section, then the features section, then the call to action section, and then finally the footer. Now I've noticed I still have this comment from a previous chapter, which we have already done, so I'm just going to delete it. So we've now added divs to our markup to act as containers. Let's see what this looks like in the browser. What you'll notice is nothing. Nothing has changed. The div element is just a structural element. There's no new additional content on the page. Now, you may be thinking, what is the point of this div element? It seems so unnecessary. The first is to improve the HTML itself, and this will only become clearer in the next chapter when we talk about semantic HTML. The second is that creating containers like this is absolutely critical for CSS. It's because we can apply styling and layout rules to a container. So for example, our call to action over here is inside a blue box. So later on, we're going to be applying a background color to this entire container. For now, just understand that the div is a structural element that helps group related content and is critical for CSS later on. Now, in our features section we looked at before, there is in fact 3 different features shown here in green that each contain a heading, paragraph, and an image. These are all smaller containers. They're divs inside another div. Let's go and add these to our HTML file. Inside our features section, I'm going to go grab a set of div tags. I'll then cut the first feature and place it inside the div. And I'll do the same to the other 2 features. Now, one thing you'll notice is that our markup does become a bit easier to read. And this is what I mean by improving our HTML code. Each feature is nicely contained within these div elements. The features and the heading are then all indented and nested inside the parent div. It's just a little bit easier to read. And this will only be improved in the next chapter when we look at semantic HTML. Including these divs will not make any difference to how our page appears in the browser. The divs are just structural units. Now, you may be thinking, how do I know where to put divs? Don't worry about this right now. The placement of divs is often more governed by what you want to achieve in CSS. And we'll be seeing this inside the CSS topic. So just don't worry about it now. Just know that you can have divs inside divs. Let's head back to the Quill homepage and add a span element. We're going to be adding a span over here, where we have the text mindful living. Doing this means that when we get to the CSS section, we can easily add the purple background just to this portion of text. In the features section, we have this same design element for simple and easy, where we'll now add a span element so we can easily add this orange background color in the CSS section. Let's jump into VS Code. I'm back in our index.html file. In our hero section, inside the heading, we saw in our design mindful living had a purple background, which we're going to be styling later in CSS. But in order to do that, we need to wrap it in some span tags. So I'm going to go grab those now. I type span and hit enter to get the tags. I'll then cut this piece of text and place it inside the span tags. We need to do the same thing in our features section. In our design, simple and easy had an orange background. So for now, I'm also going to go grab some span tags and place the text inside there. Let's check this out in the browser. And as you can see, again, nothing has changed. Mindful living, which is now in a span, doesn't look any different. The span is just a structural unit. It's there as a container to wrap the text. Finally, we'll learn how to improve clarity and accessibility of web content by using semantic HTML. We'll be talking about containers, semantic elements, and the difference between semantic elements and the div element. Now, I want to talk about containers in the real world like I did in the previous chapter. If you remember, I have my shed outside, and inside the shed, I have these containers where we store different items. Now, I actually have a very modern system for keeping this organized. I've taken photos of everything inside each container and put them in different groups on my phone, so I know what's inside each box. But imagine if I didn't do this, and instead, I just had a labeling system like this: box 1, box 2, box 3, box 4, box 5, and box 6. This labeling is not very helpful. It doesn't tell me anything about what's inside the boxes. Now, I want to show you an example of some bad markup. This is EU Startups. It's a news website that has articles about different startups in Europe and usually focuses on a company's successful venture capital raise. If I right-click and go Inspect to open up DevTools, you can see in the markup here, we have a whole bunch of containers defined by divs. For example, this navigation bar up the top is defined inside a div. And if I grab the Inspector tool, this section on Know-how and Insights is also contained inside a div. If you look at the markup, you can just see divs being used everywhere. Now, as I mentioned, this is considered bad markup. It's like using box 1, box 2 to label storage containers. Let's go back to my shed. Instead of labeling the storage containers box 1, box 2, etc., using labels like these that describe what's in the container is a lot more helpful. This now brings us to semantic HTML. The word semantic is just a fancy word for meaningful. So in other words, meaningful HTML. So what is semantic HTML? Semantic HTML is using HTML elements that describe the type of content they contain. So instead of using a generic div as a container to group related content, HTML gives us a handful of other container elements that better describe the content they contain. We're going to look at those elements soon. I want to discuss 3 reasons why using semantic elements to group content is better practice. The first is accessibility. It helps users with disabilities who rely on screen readers and other assistive technology. The second reason is SEO, which stands for Search Engine Optimization. It improves search engine rankings by helping search engines better index web page content. And the third reason is cleaner code. It creates clean and structured code that you and other developers can more easily understand. To explain semantic HTML, we'll be looking at this mockup of this fake website called Dan's UX Review. The idea of this website is to have articles that reviews the UX of different web applications. This mockup is called a wireframe. It's a simple visual guide that shows the basic structure of a web page without the design details. Now, as we know by now, all the content of this page is going to be contained inside a body tag. Let's now split this page up into 3 main sections. This top part contains the navigation menu and the main heading of the page. For this kind of section, we would use a semantic element called a header. Just like a div, the header is grouping this content, but it has a more useful name, header, as opposed to div. Headers always contain introductory content, often containing logos, navigations, and headings. Now, don't confuse header with head. The head contains information that is not displayed by the browser. We've seen things like meta tags as well as the title of the page, whereas the header is a semantic element. In the middle, we have our main content section, and we can use the semantic element called main. The main element represents the main content of a web page, and we can only use one per page. At the bottom, we have the footer, which is also a semantic element. Footers contain contact details, related links, and copyright information. Now, you can use divs for these 3 sections, but using the semantic elements is a much better approach because they better describe the content they contain. Now, there are also a handful of semantic elements we use inside this structure. For the navigation bar, there is the semantic element nav. The navigation menu typically contains links to different parts of the website. On the top left of the main section, we can see the most recent article, and we can group this content with the semantic element article. An article typically contains self-contained content like a blog post, news article, product card, or user comment. While an article is often used for an actual article, don't let the name article fool you. As I put in the description here, it's not only used for a news article and can be used for things like product cards. We have this small section advertising Notion. It's placed here because on the left I have an article about Notion. To group this content, we would use the semantic element aside. An aside is used for tangentially related content like sidebars, advertisements, or quotes. Below this, we have 2 sections. The top section contains a group of articles that are organized by industry, while the section below this has some testimonials. For these sections, we can use the semantic element section. A section is used as a thematic grouping of content typically used to divide a web page, and will usually have headings. This is getting quite cluttered, so I'm going to strip a lot away. What we're left with here is a simple diagram showing semantic elements. I now want to look at this website called smartcompany.com.au. It's very similar to the EU startups website we saw earlier, but covers Australia instead of Europe. Let's open up DevTools and check out the markup. Unlike EU startups, Smart Company is using semantic elements. For example, we can see the header. Inside the header, we can see a nav element. We can see all these different section elements. If I grab the inspect tool and click over here, we can see the article element. Now, this can seem a bit confusing with divs and articles floating around, and we will be discussing later when to use divs and when to use semantic elements. For now, I just wanted to show you some semantic elements in action. Now, you don't have to use all the semantic elements, and you can place them whatever makes sense for your design. So for example, we could have a design where on the far right, there's another navigation menu. And next to the navigation menu, we could have 3 sections. So the placement of semantic elements can vary depending on the specific layout of a page. Now, when I got started, I was so overwhelmed with being thrown all these different semantic elements and questioning myself when I should use the right one. Seriously, don't worry about this. The good news is that most web applications will follow a simple structure and won't use all the semantic elements on a single page. So for example, inside the main section, you could just have 3 sections like this. If you used, for example, the article semantic element instead of the section element, it won't actually change anything to do with your markup. It still acts as a container. So don't worry too much about memorizing all the semantic elements and overthinking which ones to be using. I would suggest just remembering the ones you see on the page now, because this structure is quite common. Having 3 big divisions in your page with the header, main, and footer semantic elements, and then inside the header, having a nav element, and inside the main, having several section containers. I want to show you this simple structure on this web application called Wise. Wise is a tool I use to transfer money overseas at very affordable rates. If I right-click and open up DevTools and inspect the top over here, you can see we have our header, and inside the header, the navigation element. Next up, we have the main element, and the main element contains a whole bunch of different sections. There's no elements like articles and asides. And right at the bottom, we have our footer. So as I've previously mentioned, this is a very common structure. And again, don't worry about all these divs floating around. A lot of the time they'll be there because a front-end framework is also in play. And that framework will often require the placement of divs. For now, I just want you to see that the simple overarching structure of headers containing navs, mains containing sections, and a footer at the bottom is a simple structure and is common. I now want to discuss semantic elements versus the div element. I want us to understand when it's appropriate to use semantic elements and when it's appropriate to use the div element. We'll be looking at the footer on the Asana homepage. Let's take a look at semantic elements first. Semantic elements provide meaningful structure, typically used for significant sections. For example, the entire footer in red is a semantic element. On the other hand, the div element is a generic container typically used for smaller groups of content. For example, to group all the links, we could use a div element. We could also use a div element at the bottom to group all of this content together. And we can also use more divs inside this div, grouping things like the social media icons. So don't just throw away the div element, it still is really important, as we're often going to want to group smaller sections of content, where using a semantic element just wouldn't make sense. Let's check out the footer in DevTools. I'm going to right-click, Inspect. The first thing you'll see is the semantic footer element, which contains all elements of the footer. You can then see we have 2 divs. The first groups all the links together, and the second groups the content at the bottom. I can continue to expand this div to see more divs grouping these pieces of content together, like the social media icons. Let's go and finish off our containers and semantic HTML summary card. We looked at semantic HTML. We saw that a page has 3 main divisions: the header, the main, and the footer. Inside the header, we often include a navigation section. Inside the main, we have semantic elements like articles, asides, and sections. And just remember, a lot of the time, we're just going to be using sections. Let's now look at adding semantic elements to the Quill homepage. The header contains our navigation bar and hero section. For the navigation bar, we can use the semantic element nav. And for the hero section, we can use the semantic element section. Scrolling down, after the header, comes our main container. Inside the main container, we can use the section semantic element to group together all the content related to the features. We can then use divs to group together each feature. So you can see here, we're using both semantic elements and the div element. Scrolling down, this part would still be in the main container. We could then use a section element to group the content related to the call to action. And then right at the bottom, we'd be using a footer element. Let's now go code this up. I'm inside our index.html file. The first thing I'm going to do is grab the header tags. Inside the header, we have both our navigation and hero section. So I'm going to cut this and put it inside the header. I'm then going to replace the divs we're currently using to group the navigation content with the nav tag. And then I'm going to replace these divs with the section tag. Next up, I'm going to go get our main tags. Inside our main section, we have the features and call to action. So I'm going to cut that and place it inside the main tags. I'm then going to replace this div with the section tag. And then I'm going to leave these divs as they are. These divs are working just fine grouping this smaller section of content. That is, each particular feature. I'm then going to scroll down and then update the div in the CTA section to the semantic section tag. I'm then going to scroll down and replace the divs that are currently containing all the footer content with the footer element. So there we have it. We're using semantic elements to properly structure our page. We've got the header at the top, the main in the middle, and the footer at the bottom. And then we're using other elements like nav and sections inside those three main divisions. And just like with divs, if I open this up in the browser, we're not going to see any change on the web page. The semantic elements are just there to better structure the HTML document itself and give meaning to each container as opposed to a general div. Alright, we've now completed containers and semantic HTML, and we'll be moving on to the last topic of the course, scientific HTML. We'll be taking a look at the origins of HTML and learn about HTML tables and other scientific elements. So before we finish the last topic, I just wanted to quickly let you know a bit more about my mission at Future Full Stack. Future Full Stack has been built to be the world's best online full stack web development bootcamp that delivers a world-class learning experience at an affordable price. As you've hopefully seen from this course, I value creating incredibly high-quality material that comprehensively covers everything you need to know in a fun and engaging way. The bootcamp is designed for complete beginners with no coding experience, and by the end, you'll be able to build sophisticated full-stack web applications. It's ideal if you're looking to start a career in software engineering or wanting to launch your own dream web applications. This HTML full course you are currently watching is part of this bootcamp, where the same high-quality teaching can be experienced in all other topics. The bootcamp is split into two major sections, where first we cover web development fundamentals, with the topics Introduction to Web Development, HTML, CSS, and JavaScript. The second section of the course is Full Stack Development, where we take what we have learned from the fundamentals and extend our knowledge to build a full stack web application. We cover the topics databases, web design, Node, Express, and React. Now, most bootcamps out there build different projects within different topics, often referred to as capstone projects. In this bootcamp, we work on the Quill Major Full Stack project, from the very first video to the very last. This approach is much smarter, as the most challenging aspect of full stack web development is getting a real understanding of how the front end, back end, and database all work together. And you will not be able to see this in smaller topic-based projects. Now, for complete transparency, the fundamentals of the bootcamp will be completely free on YouTube. This means no matter what, you can master HTML, CSS, and JavaScript without spending a cent. If you're serious about learning web development, you'd likely be paying for similar courses on other platforms. But with me, not only will you save money, but you'll also get a superior learning experience at no cost. For those ready to take their skills to the next level, I'm offering the full stack development section as a paid option. Head on over to futurefullstack.com to learn more. While I'd love to give everything away for free, I have a family to support and bills to pay. That said, even with the paid section, you'll still be saving thousands of dollars compared to a traditional bootcamp, while receiving the highest quality learning experience. I hope I've done a good job at convincing you why Future Full Stack is the best option for learning web development. But let's now get back to it. So back to the scientific HTML topic. Let's begin by learning how to organize and display data effectively on a web page using HTML tables. We'll be discussing what is a table, table elements, colspan and rowspan, and the evolution of layouts. So, what is a table? A table displays information in a grid format, arranging data by rows and columns. Here's an example of a table displaying data about popular world indices, like the S&P 500, which is the performance of the top 500 shares in the US. It presents each index in a row, and the columns display key data, like the price and price change. This is an example of an HTML table. Here is another table from a Wikipedia article, detailing Conor McGregor's UFC appearances. This table provides a summary of his various fights, including who his opponent was, the venue and the city, and other relevant information. Below this, there is another table outlining his short-lived boxing career, and where he made a ton of money fighting against Mayweather. These tables succinctly present Conor McGregor's performance history in both UFC and boxing. Let's now go through the various table elements by using Conor McGregor's UFC fights as an example. Now, I promise I tried really hard to look for a table on more important world topics, like population statistics. But I had to settle for this table because it does have some good features and data that will make teaching HTML more effective. The first element we need to look at is the primary wrapper for a table, which is the table tag. Similar to how forms work, where we had a form tag wrapping all the form elements, so too, with a table, we have a table tag wrapping all the table elements we will see soon. Inside VS Code, I'm going to go make a new HTML file. Like always, I'm going to click New File, select Text File, click Select a Language, search for HTML, and hit Enter. I'll grab the boilerplate code straight away by hitting !Enter, and then I'll save this document by hitting Command S on my Mac. Let's save it on the desktop and call it table.html. I'm also going to update the title to table. Now inside the body, let's go grab those table tags. I'm going to type table and hit enter. And as we move through the video, we're going to continue to build out our table in this file. Now, HTML tables are split up into three major sections. We first have the headings of the table, which we use the t-head tag for. This is the table head tag, and it contains heading information. Next is the body of the table, where we have the t-body tag. This is the table body tag, and it contains rows of data. And finally, we have the t-foot tag, which is the table foot tag, and it is typically used to summarize information in the table. These three tags are structural elements, kind of similar to the semantic elements header, main, and footer, which were used for overall page structure. Let's add these to our HTML file. So let's go and add those three tags. I'm first going to get the table head tag by typing t-head. I'm going to hit enter for all these to create space, because we will be entering other elements inside these ones. The second section was the table body, so I'm going to go get t-body and hit enter. And the final section was the table footer, with the tag t-foot. We now need to split our table into independent rows, and each row needs a tr element, which is a table row tag. We've added a row tag inside the table head. Next, we add 4 rows inside the table body. And then finally, we have 1 row inside the table footer. Now, just a reminder that the elements we saw before, t-head, t-body, and t-foot, are structural, just like header, main, and footer elements on a main page. We still need a tr table row tag whenever we have a row. So it means you'll often just have 1 row in your table head and 1 row in your table foot. But just so you know, you do explicitly need to define a table row wherever you have a row, even if it is containing just one row like the table head. Let's add this to our table in our HTML file. In the table head, we need to add one row, so I'm going to get the tr tags. In the table body, we have 4 rows, and I'm going to use that trick where I type tr times 4. And then I'm going to hit enter inside each of them, as we are going to be adding other elements to this soon. And then finally, we need one row tag for the footer. Now, this is where HTML tables become a bit painful. We need to define every single cell individually. Inside the table head, each cell is defined with a special tag known as the th tag, which stands for table header tag. For all the other cells, we use the td tag, which stands for table data tag. This process of defining every single cell may seem somewhat cumbersome, but it is unfortunately a necessary step in HTML table creation. It's also at this point we add in the table content. So let's jump into VS Code and write this up. Okay, I'm back in our table HTML file, and I've put the table on the right here as a reference, so we can easily see the content we need to add. Inside the T head, we have our T row. So let's go add each cell now. Now we need to use this table header tag, and you can see there are 5 different cells in this row: event, fight, venue, city, and PPV, which stands for pay-per-view. So I'm going to go th times 5. And now we enter the text: event, fight, venue, city, and PPV. Let's now go to the T body. Over here, we have 4 rows for each row of data. The tag we use here is the td tag, the table data tag. And again, inside this row, we have 5 cells. So I'm going to go td times 5. Now, this structure is going to be repeated for each row inside the table body. We have 4 rows, each with 5 cells. So I'm just going to copy this and replace each table row tag. So we end up with a table row with 5 cells in them. So let's add the content for this first row. The first cell in the row is the event, UFC 189. The next cell is the fight, Mendes vs. McGregor. The next cell is the venue, MGM Grand. The next cell, the city, Las Vegas. And the next cell, the number of pay-per-views. In this case, 825,000. Let's do the next row together. This row over here. The event, UFC 194. The fight, Aldo vs. McGregor. The venue, MGM Grand. The city, Las Vegas. And the number of pay-per-views, 1.2 million. Now, to avoid boring you, I'm just going to go fill in the other 2 rows, but it's the exact same format. Alright, you can see here I've just filled in the content, and it's the exact same format as the other 2 we did previously. Let's now move down to our table footer. Inside the foot we have our row, and now we're going to go add each cell, and we still use the table data tag. In this case, there's only 2 cells, total sales and the pay-per-views. So I'm going to type td times 2. The first cell is total sales, and the next cell is the total number of pay-per-views. Alright, so let's check this out in the browser. So here you can see our table. I want you to notice 2 things. The first thing I want to mention is that this doesn't look like a table we saw in Wikipedia, where we had lines vertically and horizontally, making the table look a bit clearer. That's handled in CSS. I also want you to notice that the first row has different styling to the rest of the table. The text is bold and centered. This styling is automatically applied because we're using a th element for the cell, whereas all the others are using a td element. Now, the most important thing I want you to see is that the table footer looks very different to the table we saw. In the table we saw, total sales spanned across 4 columns, which then pushed the total number below the other numbers in the pay-per-view column. So let's now look at how we can achieve that. So let's take a look at col span. Colspan is an attribute that specifies the number of columns a cell should span horizontally. We do this by including a colspan attribute in the table data opening tag and set its value to the number of rows we want to span horizontally. In this example, the value of colspan is 4, saying that we should span 4 columns. Let's see how this works. We need to work out the number of columns we want our cell to span. Total sales is spanning 1, 2, 3, 4 columns. So we need the cell to span 4 columns. And you can easily work this out visually. Let's go and update our table in VS Code. I'm back in our table.html file. I'm going to scroll down to the tfoot. And inside this td tag, I'm going to add a colspan. And I'm going to set the value to 4 to span 4 columns. Let's check this out in the browser. So you can see the total sales is now spanning these 4 columns, which results in this total number being pushed into the correct column. Now, something I want to do to improve this table compared to the original on Wikipedia is group together these venues, MGM Grand, which we can see 3 times, and group together the city, Las Vegas, which we can see 4 times. So how do we do that? We achieve this with rowspan. Rowspan is the opposite of colspan. Rowspan is an attribute that specifies the number of rows a cell should span vertically. Let's look at the MGM Grand cell. We can add a rowspan attribute to the opening tag with a value 3, which is equal to the number of rows to span vertically. Let's see how this works. Here we have the right-hand portion of our table, with the columns venue, city, and pay-per-view. I'm going to add in these lines to show the different rows. I'm then going to number the rows that contain the data, so I'm ignoring the header row. We have row 1, 2, 3, and 4. Looking at the venue column first, the cell MGM Grand is repeated 3 times. So here, we want this cell to span 3 rows, to end up looking like this. To achieve this, we can write rowspan equals 3 inside the first table data cell containing MGM Grand. I want to do the same thing in the city column. We have Las Vegas repeated 4 times. Instead, we want this cell to span 4 rows. So it ends up looking like this. To achieve that, we would add rowspan equals 4 into the first table data element containing Las Vegas. Let's go and write this up in VS Code. So I'm back in table.html. I'm going to scroll down to the body of the table. We can see MGM Grand is repeated 3 times, over here, and over here. So the first thing I'm going to do is add in our rowspan by typing row, and you'll see rowspan automatically comes up, so I'm just going to hit enter. We wanted this to span 3 rows, so I'll add the value 3. Now it's really important that we delete the other cells. Otherwise, what would happen is that this would span 3 rows, but these cells would still exist. So I'm going to delete this one, and I'll delete this one. So you can see the rowspan attribute is only added to the first instance of the data we want to group. Let's now add the rowspan to Las Vegas. Las Vegas is repeated 4 times, over here, here, and here. So let's go add rowspan and set the value to 4. And again, make sure you delete the other Las Vegases. All right, let's check this out in the browser. So you can see this has worked. MGM Grand is only written once now and spans these 3 rows. Las Vegas is also only written once and spans the 4 rows. Let me show you what would have happened if we didn't delete those cells. I'm going to add back in the MGM Grand. We had it over here, and we had it over here. Let me refresh. Now, what's happened is that our MGM Grand over here is still spanning 3 rows, and our Las Vegas is still spanning 4 rows. The impact this has on, say, this row is that this is in the right location, this is in the right location, but after Aldo vs. McGregor, because of the 2 row spans being defined here, it's essentially pushing this MGM Grand into the pay-per-view column, which is then pushing the 1.2 million into a totally separate column. And the exact same thing is happening for this MGM Grand. It's being pushed into the pay-per-view column, which is then pushing the 1.3 million into a new column. Long story short, just make sure you're deleting cells that need to be removed when using row span. Before we finish up, I want to quickly discuss the evolution of layouts. In the past, tables used to be the primary method of positioning elements and creating structured layouts. Here's an example of the Asana website, where this layout would have been achieved with an HTML table before 2013. Today, this is done with CSS, as CSS has become more advanced with its layout capabilities. I'm on the Asana homepage, and let's open up DevTools to see what's going on. Right-click, Inspect, and I'm going to select over here. You can see there is no table anywhere. We just have all these divs. Now, what I want you to see is next to this div, we have over here grid. We also have this other word, flex. So this layout is being achieved with the power of CSS, specifically CSS Grid and CSS Flexbox, something we're going to be spending a lot of time on in the CSS section. I now want to compare this to a much older website. This is the OG Berkshire Hathaway website, which we've looked at previously in this course. This web page is HTML only. It's got no CSS or JavaScript. Let's open up the DevTools. And you'll see straight away the table element. We've got the T-body tags, table rows, and table data. Now, on modern web applications, you just wouldn't do this, using a table to create these two columns. You'd use CSS Grid or Flexbox like we saw on the previous web page. Anyways, the point of this was just to show you that tables did once have a more prominent role in creating layouts, but this isn't the case anymore. So let's summarize this chapter and start to build out the summary card for this topic, scientific HTML. Now, in all honesty, scientific HTML isn't really a thing. I've just given this topic the title scientific, because we're going to be talking about elements that are related to data and science. We looked at the table. First, there was the main table element, which acted like a wrapper for all the other table elements. We then saw three structural units: the table head, the table body, and the table foot tag. We saw that anytime we had a row, we had to explicitly define this with the table row tag, even if there was only one row, like we had in our table head. In the body, you'd typically have multiple rows, and in the footer, you'd also typically have one row. We then saw we had to individually define each cell. For cells inside the table head, we use the TH tags, and for cells everywhere else, we use the TD tags. We also saw how TDs can span horizontally with col span and vertically with row span. Next, we'll explore how to represent specialized content with the use of scientific elements. We'll be talking about a brief history of HTML, superscript and subscript, and figure and fig caption. So let's start off with a brief history of HTML. HTML was initially developed to help scientists share their work. This is a screenshot of the first ever website created by scientist Tim Berners-Lee at CERN, which is one of the world's largest and most respected centers for scientific research. The goal of creating HTML was to allow scientists to present their papers and other scientific-related documents in web format, making them more easily shareable within the scientific community. Because of this origin, HTML includes a group of tags that allow scientists to effectively publish their work. Here is an example of a scientific document. Now, I have struggled to find early HTML documents used for sharing scientific work. So these images are screenshots of my thesis I did in my structural engineering degree. It was about the design of a bridge that could float during flood times. This was my first taste of outsourcing on freelancer marketplaces like Upwork. And I remember I got these sick renderings done for like $30. Anyways, a lot of research papers have specific elements like figures, which contains an image and figure text, where you have some kind of scientific image and short text description below. And then you have other content like equation elements. The first scientific element we will look at is superscript and subscript. This is a Wikipedia article on potassium. For any of you who have seen the Borat movie, you will note potassium is Kazakhstan's #1 export. This fact is mentioned in his made-up national anthem for Kazakhstan. One of the funniest things I have ever seen was when at a shooting competition in Kuwait, an athlete from Kazakhstan won gold, and during the medal ceremony, they played Borat's fake national anthem instead of the real one. Check it out. The next time you buy a potassium, make sure it's from Kazakhstan. Alright, back to HTML. In the Wikipedia article, you can see over here is the number 8. It's appearing above and to the right of the word knife. This is superscript. To define superscript, we use the subtags, which stands for superscript. Superscript text appears half a character above the normal line and is sometimes rendered in smaller font. Let's now talk about subscript. Over here, we can see this letter R, which is appearing to the right and below the A. This is subscript. We use the subtags to define subscript. Subscript text appears half a character below the normal line and is also sometimes rendered in smaller font. Let's go check out this page with DevTools. I'm now on the Potassium Wikipedia page. I'm going to right-click Inspect to open the DevTools. I'm going to grab the inspector element and click on the number 8. And you can see it's in the subtags. The subtags are in fact nesting an anchor tag because the number 8 is clickable, which will take you to a reference at the bottom of the page. Scrolling down, let's go inspect this symbol over here. You can see we have the subtags, which is wrapping the letter R. The next scientific element we'll look at is figure and fig caption. Over here, we can see an image of potassium and the description below it known as a figure caption. The image and figure caption make up a figure. The fig caption element is used for the description of the figure. You can see here the description is pieces of potassium metal. Above the fig caption, we have an image of potassium, so we'd use the image element. The image and fig caption are then wrapped by the figure tags, and this gives us the complete figure element. Let's go check this out in DevTools. So I've scrolled down the page and I'm by the figure. I'm going to click the inspector tool and click on the image. And you can see we have our figure here, which is made up of the image and fig caption. Now, we can sometimes encounter the figure element being used not just in scientific contexts. I'm on the Notion homepage in the testimonials section. You can see in this card over here, we have a person's image and surrounding text of their name, handle, and the testimonial itself. If I right-click and inspect to open DevTools, use the inspector tool to click on the person, you'll see we have the image, which is wrapped by a figure, and the person's name and handle is wrapped inside a fig caption. Now, I wouldn't say this is overly common, but I did just want to show you that it is possible to do this. I'm now on the IKEA page, and this catalog could be a great candidate for the figure and fig caption. If I right-click and open up DevTools, I'll click on the image of the sofa, and you'll see a figure is not being used. Just divs, images, and plain old text, with the H3 over here. So it's not super common to use figure and fig caption, but occasionally you might find it being used. So I just wanted to highlight that. So let's finish off the summary card for this topic, scientific HTML. We looked at scientific elements. We first looked at super and subscript. Superscript text appears half a character above the normal line. In this example, the 2- is in superscript. Subscript text appears half a character below the normal line. In this example, the number 4 is in subscript. We then looked at the figure and fig caption tags. The figure tag is the main wrapper element, which contains the figure elements. It can contain an image and a fig caption tag, which is used to describe the image. Congratulations, you've made it to the end and now have a solid foundation in HTML needed to work on professional projects. The next step is to learn CSS, which is responsible for visual styling and layout, and converts plain HTML content into beautifully designed web pages. You can join my CSS full course for free on YouTube, where you'll experience the same high-quality teaching and continue to work on the same project, where we'll go from this to this with the power of CSS. Also, make sure to subscribe to the channel to stay in the loop with new releases. And if you are serious about learning full-stack web development and interested in joining my bootcamp, make sure to head over to futurefullstack.com. See you in the next video.